welcome once again to a discussion of distribution of mass, which is interconnected with, actually, distribution of mass is the context of the terms balance, tail heavy, or nose heavy. Each is made up of, each is a reflection of, or a facet of, correct distribution of mass or distribution of mass in general. So, I'm saying here some things that I posted in comments and other places. So that here I'm trying to make it clear that there's more to an airframe than its CG. A lot more. And its mass and its distribution of mass are all a part of balance. And it's a simple idea, you know. Suppose you put a rock at the tail end of the model. Is it going to fly well? No. Because you screwed up its balance and its distribution of mass and everything. It's just that simple. So, I've got a visual aid for this, some of this stuff coming up. I've said this, most of this before, and that the center of mass, it's accurate to think of the center of mass not as a point, but as a volume, as a sort of a teardrop shaped volume that is centered but offset. Centered in an offset fashion on the exact point of the center of where the center of mass is, which is at 25% of fuselage length on the thrust line, or on the ideal thrust line, one might say. Here, more of the same things of understanding that from the very beginning, a builder, or model builder, a scratch builder should, you know, it behooves him to have all this stuff tucked away in the crannies. Alright, so the idea of the center of mass being a volume within the fuselage, asymmetrically centered on 25% of fuselage length on the thrust line. This is just a simple case scenario, easy way to talk about it. As you may notice, the shape of the fuselage mimics the shape of the center of mass volume, and vice versa. The one reflects the other, or I don't care. One is the chicken and one is the egg, but either way, they're shaped the same, and they should be. This is the ideal shape, and that's why a fuselage is shaped like this most of the time. And the basics of balance and distribution of mass always has to integrate the fact that the CM is at 25% of fuselage length, and that the tail is 3 units from there, and the nose is 1 unit from there, roughly. You end up with a roughly 1 to 3 aspect ratio, or moment arm, in a conventional fuselage. And it's a lever, and a little bit of weight over here takes a lot of weight over here to counterweight it. That's why making the tail is so making the tail as light as possible and practical is so damn important. The aft fuselage is the same way. It should be made as light as possible because there's no way out to about here we have a 1-to-1 with the leverage, and that's not terrible, but you know, from there on it climbs up. So a gram out here costs 3 grams over here. Even if you don't want 3 grams, you got to have them. Okay? So, and finally, in the olden days, this is how models were made light. These are called cutouts, I think. The use of panels and formers together creates this structure that you can remove the webbing from and reduce a whole lot of weight aft of the CM, which is just, you know, which is really good news. But, you know, this could be done, these cutouts could be done anywhere you see a panel. A builder should consider whether a cutout could be put there. And especially at the tail, stabilizers should be made as light as practical and not just made out of sheets of whatever. You can do this with foam board. You just cover it. Once you're done, you cover it with your favorite color of tape. Not duct tape, preferably, but lightweight packing tape. And, you know, I can't get colored tape around here, so mine would be see-through. But an opaque packing tape, you know, would be ooh la la. It would work fine. And I'll close with those remarks. Thanks.